Okay, so it says the shop repeats the quality check. This time, the shop randomly selects a sample of 100 chocolate bars, so much more than we did before. By sketching the probability density curves for the single chocolate bar in part 2, the sample of 10 chocolate bars in part 3, and this sample of 100 chocolate bars, describe how the probabilities change as the sample size increases. Okay. So I'm going to draw it on the same diagram just for the sake of illustration to see what's going on. So this is my first just single chocolate bar. That's my first curve. Okay. So if you like, this is my sample size where I just have one chocolate bar. Okay. Now obviously this is going to be centered around 150. Okay. However, the distribution is going to be, well, the first case, the standard deviation was 5. This will be 145. This will be 140. This will be 135. And if I go the other direction, this is going to be 155, 160, 165, and 170. Actually, I didn't need that 170, did I? Because I've got my 3 standard deviations. Okay, so in other words, this is my mean. Okay, now can you help me out? Can you describe to me what should happen as I get more and more things in my sample? Okay, so what would happen to this curve?
Outlier values, probability of having outlier values will decrease, so the outskirts, I guess,
Yes.
will get closer
To the line, good.
line.
So 0, yeah.
And whereas the value close to the mean will get more densifies, so the line will get further away.
Yeah, absolutely. I agree with that. So yeah, it's basically central limit theorem. It says, okay, as n increases, as I get more and more things in my sample, I get a truer representation of what should happen at the population. In other words, values which are close to the true mean, 150 I'm proposing in this case, should get higher. There's a higher chance of getting values closer to 150 if I have a sample size which is bigger. Clearly, if I'm taking the mean of that big sample, it should be the same as the mean of the population, or pretty much close to it. So values further away from it should have a lower probability of occurring, right? So you're absolutely right, I should end up with a curve that looks something like this. Okay, so that would be, for example, for n equals 10. You can see exactly what I've just described. There's a higher chance of getting values closer to the mean, but values further away from the mean, they start to decrease, right? And then clearly for values which are 100, okay, so sample size of 100, I should expect a really quite peaked curve. So something really like this. And obviously this is just a sketch, so it doesn't matter if it's not exact. But you can see in this case, values which are close to the mean have a really high probability of occurring. But further away from the mean, these values have suddenly dropped right down. Okay. Now, of course, in reality, these curves may look exactly like this. But my point is that I've tried to illustrate the 2 key principles. As the sample size increases, so let me write this down. So I can say, as the sample size increases, or as n approaches infinity, because n is the sample size and it's getting bigger, 2 things happen. Number 1, the sample means, so x bar, should approach the true population mean. And you can see this, okay? If I'm taking the mean of all of these samples, the first black curve is just one sample, or just a sample with one thing in it, then clearly, you know, the mean was kind of all over the place. So it was centered around 150, yes, but I could have had values each side of that. But then clearly as I move to the blue curve, it becomes more centered around that true population mean of 150, and the red curve becomes more centered still. So that's the first thing that happens. But also you notice that the spread of the standard deviation, or the spread of the curve, which is the standard deviation, approaches 0. Okay? So literally in words, okay, it becomes more centered. And the spread decreases. What this means, from a practical point of view, thinking about probabilities, is that probabilities close to the mean, so probabilities close to the mean, decrease. Sorry, they increase rather, so they increase. Probabilities further from the mean decrease. All right. So to be honest with you, this is what this question is getting at. So sketching probability density curves for the chocolate bars in 1, 10 and 100 sample sizes describe how the probabilities change as the sample size increases. So first of all, you need to draw these curves and you need to show that this clearly happens. It becomes more centered around here and the spread decreases further away. I've also just re-emphasized this in words. Okay, it's just to make sure that whoever's reading this or whoever's looking at this, I know it's obvious looking at it, but whoever's looking at this really knows that you understand what you're doing. But it does also mention talk about the probabilities. That's what the question's asking. So it is really important that you talk about what happens to probabilities close to the mean and probabilities further from the mean. Okay? Does that make sense? Right? So you're happy, this is just literally something called the central limit theorem. Okay, CLT.